Hello guys, myself Pawan and you are watching Optimistic Coder, and in this video we are going to discuss about relational and logical operators in detail. So before that, if you are new to my channel and you are interested in programming, data structures and algorithm, I would recommend you to go subscribe to my channel and turn on that notification bell so that you get updated every time when I upload a new video. So when that is clear and that is sorted, let's roll the intro. So in case of relational operators, we basically have 6 different operators, that is less than, greater than, less than equal to, greater than equal to and not equal to. So let's understand all these operators in Eclipse. So I have created an operator class and within that I have created a main function. So now I will be writing simple print statements and within that we will just write these conditions to check what is the output that we get in different type of data types and different type of operators. So now if I write a simple print statement and within that if I write 50 is greater than 40, for example 50 is greater than 40, if I save and run it, I can see that the output is true. So this is perfectly valid and this is the way how we are going to use a relational operator. So if I write for character value like a is greater than 50, this is also perfectly valid and it can be written in this way, and you are going to get a boolean value for this also, that is true. So if I try to execute it, you can see it's true. So if I even try to compare two character values with each other, even that is valid and it will return you a boolean value false. So now if you try to execute it with float type, for example if I write 40 is less than 70.6, so this is a double and numeric value. So now if I try to execute it, it's giving you the value as true. So you can compare all kinds of primitive data types that you have, but you cannot use true and false, that is boolean value, for less than, greater than, less than equal to and greater than equal to symbols operators. So now these four operators will not support boolean data type. Now if I write system.out.print true is greater than false, so now it actually doesn't execute and it will show you a compile time error saying that operators cannot be compared, the boolean operators cannot be compared. The reason behind this is if you try to compare boolean value true and false both are at same level, so on what basis you can say that true is greater or false is smaller? So that's the reason why the compiler is going to throw a compile time error saying that boolean operators cannot be compared. So for less than, greater than, less than equal to and greater than equal to, for all these four relational operators, boolean data type is not supported. Now in case of object types, now for example if I try to print to string value, if I try to compare to string value and if I write the values, it will show you again an error saying that these two values cannot be compared, and the you can see the error, that is java.lang.string and java.lang.string cannot be passed as an argument type, and this is not valid. So now why it is not valid? Because an object type values cannot be compared saying that this object is greater or this object is smaller. But for example if you take an example of an employee class, and in that if you are creating two employees and you cannot say that employee 1 is greater than employee 2, you have nothing to compare with, and you can't say that this object is greater than this object, or object employee 2 is smaller than employee 1. But you can compare it by saying that employee 1 age is greater than employee 2's age, or else you can say that employee 1 salary is greater than employees 2, or you can say the year of experience. So you can say the parameters of that employee and then you can compare. Simply you cannot say that employee 1 is greater than employee 2. It actually doesn't make any sense. So that's the reason why compiler is going to throw you an error and say, because object types cannot be perform any kind of comparison. So for less than, greater than, less than equal to and greater than equal to, for all those four relational operators, object types are not valid and Boolean types are also not valid and it cannot perform any operation. And if you perform any relational operation with these operators, you will get a Boolean value in return. So this is all about the four relational operators, that is less than, greater than, and less than, equal to, greater than, equal to. But if you are trying to use the operators equal to and not equal to, in that case you can see these values like object type, boolean type, everything is supported. Now if I write system.out.print, if I try to compare a numeric value like 10 is equal to 10, it is perfectly valid and it is going to give you the value as true. Okay, so but in that case if I write here the boolean value like true is equal to false, even that is perfectly valid, and if you try to execute it, it will show you as false. So now why this happened is because both true and false are at same level, and now you are just simply checking whether true is equal to false or not, and we know that true is not equal to false, so that's why the reason we are getting false as an answer. But if you have written here true is equal to true, which means that true is equal to true, so that's correct statement, so you will get the output as true. So if I execute it, you can see the value is true. So now if I try to execute the same thing with the not operation, so if true is not equal to false, so if I execute this particular statement, this is also even valid, and it says that true is not equal to false, which is a valid statement, so you will get the result as true. Whereas if I write here as true is not equal to true, so that is valid and you can see the answer is false. So for the relational operators, you need to have some conclusions in your mind. So the conclusion in relational operators that we have is, if we are using less than, greater than, less than, equal to, or greater than, equal to, boolean types are not allowed, object types cannot be compared, and the value that you are getting will be of boolean type in return, the results. And for example, you are using equal to and not equal to, in that case boolean type will be supporting you, any other primitive data type will also be supported, object types are also be supported. So to show the object type, let's compare two strings equal to, so in that it will just compare both the object name and it will give you the value as false. You can see the value is false. So that's the way how we are actually doing all the relational operation. So now in the case of logical operators, we basically have three operators: and, or, and not. So now in and operators we have a criteria. I have actually explained this thing in Bitwise and an or operator already, that how an and or operator is going to work. But for now, if you consider in a basic simple manner, if you are giving two inputs to an AND operator, and if both the inputs are true, only and only if both the inputs are true, the value will be true, otherwise the value will be false and you will not get any kind of true value. But whereas in the case of OR operator, if any one are true, both regardless whether the second input is true or false, it will be true. But if we already have bitwise AND operator and OR operator, then what is the need of a logical and a logical OR operator? The reason is, if you are performing a bitwise AND operator, then there is a time lag issue. Now what is that? Let's see. So for now I will just write a simple code. Okay, so I have written the program. So basically I have not explained anything about control statement in my video. So for now you just understand that if you are writing this control statement, that is if else condition, in that if this condition that I have written in the if block, in the if condition, if that is satisfied as true, and if it is true, only then this particular block of statements will be executed, or else else block will be executed. Okay, so if I try to execute now this operation, this particular snippet of code, and in which I am using a bitwise AND operator, not a logical AND, because logical AND will have two ampersand signs. So if I am using a bitwise AND operator, then what is the difference? Let's see. So now as we know, I have done a post increment in here. So a will be incremented whatever, and it will check the condition. So the a is having 5 and the value which are comparing is 10. So it is saying that 5, or if it is post incremented 6, it is greater than 10. So it is obvious that it is going to be false in this particular statement, in this particular condition, and we are performing another and, that b should be less than 10. So that is also false. So in that case, let's see, if I execute it, else part should be executed, right? So if I execute this particular statement, you can see the value is else is executed, and the value of a has become 6 and the value of b has become 21. Perfectly fine, it's done everything that is needed to be done as an AND operator. And if I perform the AND operation, that is logical AND, here also if I try to execute, it will execute properly as an else block. The else block only executed, if block is not executed, and it is working exactly as a bitwise operator, bitwise AND operator. If it was also able to do the same thing, then why the need of logical AND? So the answer is, if we are performing bitwise AND operator, then it will execute both the condition even if it is necessary or not. Now what does this mean? So in the case of AND operator, we know that both the conditions must be true, then only the value is true, and we have to execute the if statements, if block condition, if block statements. So if I am checking this first condition, and if that condition itself is false, then is it necessary to check the second condition? The answer is no. So in the case of bitwise AND operator, if I see, it will go and check this condition, and then if that condition is also wrong, but still it will go and check the other condition. It will not see, it will not bother about it is false or true. It will go and execute both the condition. Now in this case, if I try to execute it, you can see b value is also incremented because it has executed this part of code. So if I do the same operation with the logical AND operator, and if I try to execute it, you can easily find the difference that b is not yet executed. It means that it has not yet seen the second condition itself, and it has properly executed the else block. Because of this reason only, we are using logical and an or operator. So in real time scenarios, for example, you have a login page, and in that you have username and password. So in that case, if username itself is wrong, so checking password and giving the output then will be a waste of time. So system time will be wasted in that. If now we are executing, it is executing very fast because the addition and the program, it is working locally. But if you are making a big enterprise application, and in that if you are using bitwise AND operator, and if you think that the first condition, for example, this first condition is taking 1 minute of time to execute and give you the output as true, and if I execute this also for 1 minute, so it is wasting 2 minutes. But instead of that, if I try to execute it for the first time, and it is giving you as a false value, then why should I waste another 1 more minute checking this? So that's the logic behind logical and or operator. So that's the reason why we don't use bitwise and an or operator in these kind of conditions. So that's the way how we are going to use an AND operator. The same way we are going to use the OR operators also. In OR operator, we are going to use two pipe symbols. So in this, any one of the condition must be true. If any one of the condition is true, then only it is going to execute the if block. So in this case, in OR operator, if the first condition is checked and it is true, it will not go and check the second condition. Whereas if it is false, then only it will go and check the second condition. Okay, so now if I execute it and if I run it, we know that the first statement is false. First condition, a is incremented, a is greater than 10 is false. So it will go and execute the second one also. So we can see that a is also incremented and b is also incremented. If in that case, if I write here as like this, so the first condition is true, so it will not go and check the second condition, will directly execute it. So we can see if block is executed and the value of a is 20. So that's a basic difference that I want to show you about the bitwise and logical and or operator. So that's the way how we use and or. So in case of not, it is pretty simple and easy. Now if I try to write a statement, for example a print statement, system.out.print, and in that if I put a not operator, and within that in front of a condition like 4 is greater than 5, so we know that 4 is not greater than 5, and the value that you should return, that the value it should return is false. But because we have kept a not operator in front of it, if we try to execute that particular statement, it will return you true. So whatever the answer that you have, is it false or true, it will just reverse the value of that boolean type. So this is the way how we are going to use not operator. That's all in today's videos, guys. I hope you liked the video. If you liked it, please hit like and comment below, and don't forget to subscribe my channel. And if I have to improve something in my content, please let me know in the comment section. Till then, bye.